Hello, I'm Dr. Papia Bhattacharjee. Recall that in the previous video, we have computed the first and the second derivatives of this function y equals x over natural log of x. Now in this video, we will use these two derivatives to figure out if the function has any extrema or inflection point. So for relative extrema, we need to find critical numbers. That's where the first derivative is 0 or undefined. So look at the expression for first derivative. We have a numerator and a denominator. Now the derivative will be 0 if the numerator is 0. So where is natural log of x minus 1, 0? Okay, it will be when ln of x is 1. Now where is natural log of x equals to 1? We can use the inverse property of natural log and exponential function to say that this is 1 for x is equal to e to the power 1 or e. So x equals e is a possible extreme. Now which one is it, max or min? To check that, we can take the second derivative and plug in x equals e and see what happens, right? And we have second derivative right here. So we can just use this expression. But notice that we can simplify this expression a little bit before we work with it, since we have a fraction within a fraction. So let's do that. Note that in the numerator, we can add these two expressions together with a common denominator, and the common denominator is x. So we have negative of ln of x plus 2 in the numerator. And the denominator is natural log of x cube. And that, to write it as one single fraction, that is equal to, the numerator stays in the numerator. So let's just switch it, 2 minus natural log of x, and this x comes in the denominator with the ln of x cube. So that's a much simpler expression to work with. So we're going to use that right here and see if we can figure out what happens to the second derivative at x equals e. Okay, so use the expression. So it will be 2 minus natural log of e, plug in e wherever there is x, divided by e times natural log of e cube. Now what do we know about natural log of e is 1. That's how we solve this equation right here. So this is 2 minus 1 over natural log of e is 1. So 1 cube is 1 in the denominator. This is just e. And you notice that this is just 1 over e, which is a positive quantity. Okay. Second derivative, positive. What does that mean? That means the curve for this function right here, it's concave up. Positive means concave up, and concave up means it has a minimum. So we know that x equals e, the function will have a minimum. So let's come back here, and in our relative extrema, we write that down, that x equals e is a min. And we'll use that fact to graph the sketch of this function. Okay, what else? Are there any other extrema? This is when the first derivative was 0. What if the first derivative is undefined? That could be another extrema as well. Now where will it be undefined? If the denominator is 0. Now what happens if natural log of x is 0? Before we even solve this equation, let's think about it. Look at the function itself. If the denominator is 0, the denominator is 0 for the function expression also, which means the function is not even defined there. So we can't have any extrema. So we don't have to solve this. We can immediately say that this means the function is not defined. And so we don't have to worry about that. So only one extrema, and that's a minima at x equals e. Okay. Now, let's see if we can figure out any inflection point. For inflection point, we need the second derivative to be 0 or undefined. Let's talk about the undefinedness first. When will the second derivative be undefined? If the denominator is 0. When will the denominator be 0? Look, there are two expressions. One is x, one is natural log of x. So it can be that x is 0 or natural log of x is 0. But for either of these situations, again, our function will not be defined at those values, right? We already have said that x has to be positive, so x cannot be 0, and we just saw what happens when natural log of x is 0. So these two cases, function is not defined again. So we don't need to worry about those cases. Only thing we need to worry about is when the numerator is 0. And the numerator is 2 minus natural log of x. So when is 2 minus natural log of x 0? Well, this happens if ln of x is 2. And again, you can apply the property of exponent and natural log to say the solution is x is equal to e square. So a possible inflection point, but we're not sure yet, right? We have to check if really the concavity of the graph will change to the left and the right of this point. So let's consider the real line. And here is our, say, e square is right here. And we have to figure out if the function is changing concavity. So the best way of doing it is just choose a point to the left of this number and to the right of this number and see what happens to the second derivative. And the easiest point that I can think of choosing, since this is e square, just choose e here, a point, and choose, say, e cube. Okay? So here is our second derivative expression. Let's not write everything down, but just get an estimate and get an idea of what the sign will be. That's all we care about, right? Now the denominator for e and e cube will always be positive. We don't need to care. Just look at the numerator. So what about the second derivative? The numerator, c, will be 2 minus ln of e, okay, over something. Now this is 2 minus, natural log of e is 1, so 2 minus 1 over something, and that is definitely positive. So on the left side, second derivative positive means the function is concave up. The right side, for e cube, this is 2 minus natural log of e cube over something, that's always positive. But natural log of e cube, using the property of natural log, is just 3, right? You bring down the 3. So this is 2 minus 3 over something, and that is negative. So on this side, it is concave down. Concavity changing, therefore e square is an inflection point. So come back here, and let's write it down, that x equals e square will be an inflection point, and we know that it will be concave up to the left and concave down to the right. So I would like to keep that information here as well. It will help us when we graph. So we have e square, and to the left we'll have concave up, to the right we'll have concave down. So we will move on to our next video, and we will figure out asymptotes to the graph of this function.